Welcome. So we solved this problem in our last podcast. And so we used rational root test and then factor by grouping and factoring a difference of squares to find our 4 solutions. We're going to solve this same problem a different way. And this new way that we're going to learn is called substitution. You can use substitution if there is 3 terms. So this, I believe, is already in your notes as well as up here. You can use substitution when there are 3 terms and the exponents are in doubles, like x to the 4th and x squared, or x to the 6th and x cubed, x to the 8th and x fourth, and so forth. To use the substitution, we're going to let x squared equal w. So substitution is going to allow us to work with smaller exponents. And then we're going to be able to apply the exact same steps that we used for factor by grouping for quadratics. We just have to remember to substitute back because we're using w's rather than x squared. So we do have to substitute back. So let's see how this works. The nice thing is when this technique works, there's no trial and error, and it's a fairly quick technique. All right, so step number 1, and I believe these steps are in your notes already. If not, they'll add those in. Step number 1 is we're going to replace x to the 4th with w squared and x squared with w. Now, why are we replacing x to the 4th with w squared? Well, let's think. So x squared, don't write this down. If you wanted to write it down, you can write it off to the side, but don't write it right here. I'm just using this base because it's right in the middle. All right, so x squared squared, right? When we raise power to a power, we multiply the exponents. That's like multiplying x squared times x squared, right? If we're squaring x squared, we're multiplying x squared by itself. Right? Well, x squared times x squared is x to the 4th. Right? So since w is replacing x squared, w squared is going to replace x to the 4th. Right? Because x squared is just x squared squared is x to the 4th, right? So that means w squared is going to be x to the 4th. So we're going to replace. So instead of having x to the 4th, we're going to have w squared minus 13w plus 36. We want to use a different letter, and we use w because that's a good letter. It doesn't look like a number, right? We want to use a different letter so we don't get confused and think we're solving for x. Because we're not, we're solving for w. We have to, after we solve for w, then we're going to solve for x. All right, so now we can use factor by grouping because we have 3 terms and it's a quadratic. Okay? And so w times 36 is 1 times 36 is 36. So multiplies to give us 36, adds to give us negative 13. Well, that would be negative 9 and negative 4. By the way, if this were not factorable, don't proceed. It would probably be best not to proceed with substitution and instead probably go back to solving using the rational root test. It may be more complicated if you try to use one of the other techniques because you still have to remember that that's not w, that's x squared. With factoring, it will be easy to make the replacement and then solve. It may be a little bit more complicated if you try to use one of the other solving techniques. So make sure you're using factoring, right? Because we're going to be able to factor the whole way here. Right? So we're going to use factor by grouping, and we're replacing the negative 13w with negative 9w and negative 4w. And it does not matter who goes where. And don't forget, the first and last terms stay. They're not changed. The first 2 are a group, the second 2 are a group, and we pull out our common factor. Right? So common factor for w squared and negative 9w is a w. If we divide w squared by w, that would be w. Negative 9w divided by w is going to be a negative 9. Right? So now for negative 4w and 36, they're both divisible by negative 4. Right? We definitely want negative 4, right? Because we were going to want the second binomial to be positive minus a negative, right? You're positive and then a minus. All right, so we'll factor out the negative 4. Negative 4w divided by negative 4 is w. 36 divided by negative 4 is going to be negative 9. And look, there's our repeating binomial. So we can factor out the repeating binomial. That gives us w minus 9. And then don't forget our leftovers, right? That's our other factor. When we factor out the w minus 9, we're left with our other factor, which is w minus 4. Now we're going to substitute back the x squared for the w for the x squared, right? So don't set w minus 9 equal to 0. Don't set w minus 4 equal to 0. Those answers will be wrong. Continue on by substituting back. So we have 0 equals x squared minus 9 and x squared minus 4. Those are differences of squares. Remember that I showed you a shortcut for factoring differences of squares, right? We don't have to do all the steps for factor by grouping. We can just use a shortcut, right? Because this is always going to be square root minus square root plus square root. So this is x squared minus 9 will factor to x minus 3 times x plus 3, the two square roots. X squared minus 4 will factor to x minus 2 and x plus 2. And now you can set all those equal to 0. X minus 3 equals 0. X is 3. X plus 3 is 0. X is negative 3. X minus 2 is 0. X equals 2. X plus 2 equals 0. X equals negative 2. All right? So really a pretty quick solving technique. We did that pretty quick, and that's with me talking. Right? And we can check back and see if we got the same answers as we did before. And we got the same answers. We got 2, negative 2, 3, and negative 3. Right? So this can be a little longer technique if I don't choose the right number. Right? I may have to try more than once. So if I didn't choose 2, negative 2, 3, or negative 3, then I wouldn't have 0 as a remainder, right? And I'd have to try again until I got one, a solution that gave me 0 as a remainder. Here, with the factoring, substitution, and factoring, there's no trial and error, nothing we have to test. And there's no need to do the rational root test here, right? Because we're going to, if we can't factor, when we first try factor by grouping, if there really was nothing that would have possibly multiplied to give you 36 and added to give you negative 13, well, then we'd go back and use this technique. Right? But with substitution, you don't have to check which numbers could be possible solutions because you're going to get those solutions once you factor. Right? So there's really no reason to do the rational root test here. Right? We just substituted so that we had something with smaller exponents. Then we were able to factor. And then once we factored, we substituted back, and we factored one more time, got our solutions. This has other applications beyond just being able to solve polynomials. You may see some in this course in Algebra 2. More likely, you'll see them in later courses, pre-calc and calculus, where you're using substitution to be able to factor something more easily. So this is a really good technique to learn. All right? Let's go on to this one. And so when I'm choosing a solution, a technique to solve, I always look for the factoring ones first. And then if that's not going to work, then I go to the rational root test. Right? So here, pulling out a greatest common factor, it's not going to work. There is no number that divides, other than 1, that divides evenly, or negative 1. 1 and negative 1, that divides evenly into 2, negative 3, negative 8, and negative 3. Right? So there's no number, no term. So pulling out a greatest common factor is not going to work. Factor by grouping, it just doesn't even look promising. Right? If we were to look at these two groups and we pull out a common factor, we're not going to get that same common binomial. There's no way I'm going to pull a factor out of 2x, so if I pull a factor, the greatest common factor here is 1. So I'm going to be hoping for another 8x minus 3 over here. There's no way I'm going to get an 8x minus 3. So it doesn't look promising at all for factor by grouping, so we wouldn't even try. That means we would need to use this one, right? That would be our choice. Another podcast coming up, I'll have them all mixed up, and we'll go through what would be the best choices. And actually, you're going to get to choose what you think would be the best choice, and then I'm going to show you, and you'll see, did you make a good choice? All right, so the rational root test. Our constant is -3, the leading coefficient is 2, so our possible solutions, well, neither one of these has a whole lot of factors. So we're going to take all the factors of -3, and really, it doesn't matter whether it's negative or positive, right? Still going to have the same factors, but all the factors of -3 and divided by all the factors of 2. Right? Well, the factors of -3 are going to be 1, positive and -1, and positive and -3. And the factors of 2 are positive and -1 and positive and -2. Right? So we're going to divide positive and -1 and positive and -3 by positive and -1 and positive and -2. Right? So if I divide 1 by 1, 1's a solution. If I divide 1 by -1, -1's a solution. If I divide 1 by 2, 1/2 is a possible solution. And actually, let me move this over. I don't want it to look like these are our solutions. These are our possible solutions. There we go. And then if we divide -1 by, -1 by 2, we'll have -1/2. And then we do the same thing with a 3. So if we divide 3 by 1, we get 3. If we divide negative 3 by -1, we're going to get -3. Or you can think of it as, either way, if you're dividing 3 by -1, it's -3. And if you're dividing -3 by 1, it's still -3. Right? And then we have the same thing with 2. So positive 3 divided by 2, -3 divided by 2. Here's your last two possible solutions, 3/2 and -3/2. So by the way, I don't think I mentioned it in the last podcast, you can only use synthetic division with some of these, right? So the integer solutions you can use synthetic division with. I did make that a fill-in, though, on the little practice to see that if you would catch that and be able to figure it out. And I think you probably did. I haven't checked. So here you can use synthetic. Not going to work with the fractions, right? It will mess it up because you're not dividing by x plus or minus a constant. Technically, if it's 1/2 is the solution, then the factor, so if this is the solution, the factor is actually going to be 2x minus 1. Because that would give me, when I set that equal to 0, that will give me 1/2. Right? So we can't have a coefficient in front of x, and that's what a fraction will give us. It won't work out to the true answers. It just will not give us the same divisor. So you have to use long if you're going to try a fraction, and you can use synthetic if you're testing an integer. Now we test the integers first, and if there happens to be a fraction that's one of our solutions, we're going to try to get that with, if we've got one integer solution, we're going to get the fraction solutions by factoring. Otherwise, we'll have to switch and do long division. Just wanted to make sure that was clear. Right? That you can't use synthetic all the time. It has to be that you're dividing by x plus or minus a constant. And that's fine for checking 1, -1, 3, and -3. All right, so our steps. All right, so I've got 4 to choose from. I'm just going to go in order. Let's try 1. All right, and then we rewrite our equation there. That looks a little better. With just the coefficients, nobody's missing. Cubed, squared, x, constant. We're all good. All right, so we have 2, -3, -8, -3. Bring down the 2. 2 times 1 is 2. -3 plus 2 is -1. -1 times 1 is -1. -8 plus -1 is -9. And you can see this is just not going to be promising. So no. Don't feel you have to write the no down, all right? You don't have to write everything I try. Well, just you can just write the yeses. But in your notes, let's write down under solutions that -1 was a no. Maybe we'll put it under solutions. Again, I don't want it to look like it's a solution. So, or even better, let's do this. Excuse me, 1, positive 1. Let's just cross him out. So in your notes, just cross off 1 because that one didn't work. To save a little space, I'm going to get rid of that. I'm going to get rid of that. I'm going to get rid of that. I'll keep everything else and just make this a -1. And now let's try -1. Right? So that's how we'll keep track. We'll write all our possibles there and we'll cross them off if it's a no. You just do the cross-offs and you can wait to write the notes down when we get a yes. Now if you want to attach it and just kind of so you can see later, that's fine, but I'm not going to require that you write the no's down. All right, bring down the 2. 2 times -1 is -2. Add, we get -5. -5 times -1 is +5. Add, we get -3. -3 times -1 is 3, and that one worked. We've got one. That worked. That gave us a remainder of 0. Right, so that's our remainder. So if the remainder is 0, that means that x equals -1 is a solution. If they asked you about the factor, let's say on a benchmark they said, what's the factor that's the solution? Well, if x equals -1 is the solution, x plus 1 is the factor. Because maybe they're going to give it to you in factored form, right, and ask you to figure out. And it's not something you're going to be able to factor without using synthetic division. So just so you know that if -1 is the solution, right, x plus 1 has to be the factor. Because if I said x plus 1 equal to 0, right, I subtract 1 from both sides, I get -1. Let's find the other factors. Right, and so we have 2x squared, let me switch colors here, 2x squared minus 5x minus 3. Let's always try factoring, right? Because you're going to need to know what the factors are. You may be asked, what's the factors? Not just the solutions. You need to know both, right? So the other techniques, especially with solving polynomial, they're going to be our last resort, right? If it's something we absolutely can't factor, like a sum of squares, then we can use solving by square roots, something like that, all right? 2 times -3 is -6. So we need two numbers that multiply to give us -6, add to give us -5. Right? Well, that's going to be -6 and 1. Right? Multiplies to give us -6, adds to give us -5. -6 only has 2 sets of factors, 6 and 1 and 2 and 3. Right? So it doesn't take you long to go through those 2 factors and figure out which one it was. Right? So 2x squared, and it doesn't matter who goes where, I'll just go in order. -6x plus x and -3. So notice the -5x has been rewritten into -6x and x, because if we knew what the factors were, which we will in a moment, and we multiplied them, these are the 4 terms that we would get. And then we would say, hey, -6 and x, I can combine those. That's how we get -5x. So the first 2 are a group, the second 2 are a group. We can factor out a 2x. That'll divide evenly into both of them. 2x squared divided by 2x is x. -6x divided by 2x, that's -3. And only common factor here is a 1. Right? So we can factor out the repeating x minus 3. The leftovers would be our other factor once we factored out the x minus 3. So we have 2x plus 1. Now, if it asks you for this factored, and it's not something you could do without using synthetic division. That's okay, because now I've shown you how to change it back to a factor, from a solution to a factor. All right, so I'm going to list the other factor here, and I think that's a very good habit for you to be in, to get into, because then you will not forget to give me all three solutions and not leave -1 stuck up there and forget all about him. So our solutions, we have x minus 3 equals 0, so x is 3. 2x plus 1 equals 0, so we'd have 2x equals -1, divide by 2, x is -1/2. And the last one, x plus 1 is 0, x is -1. So the solutions were x equals 3, x equals -1/2, and x equals -1. Those were actual solutions, right? But we got to the -1 using synthetic division. We factored to get the other two, but remember what the three factors are, because there may be a question on a formative or benchmark that asks you for this factored, and you would have had to have used synthetic division along the way. All right, so here's this one done. All right, let's do another one. We're on a roll. All right, so here we have 3x cubed plus 12x squared plus 3x minus 18. Now you can solve it as is. However, if you like, you can factor out the constant, greatest common factor, and divide both sides to reduce. What would be the benefit? Well, let's take a look. I'm going to write, and you're going to write, the possible solutions for both equations. First, we're going to do the one that is not, that GCF was not factored out. All right, so my P here is -18. That's my constant term. I'm going to write constant because I actually have seen P and Q reversed in different textbooks. It's not so all important that we call it P and Q. Plus we use P and Q for intercept form. It's more important that you realize constant and leading coefficient. I don't care what you call it. So -18 and 3 are the two values. So our possible solutions, we're going to divide all the factors of 18. So that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. And divide that by plus or minus 1 and plus or minus 3. Right, I'm not going to write all these out separately like I did on the other page, but let's count. Let's just count how many we have. All right, so we have 2, 4, 6. So I'm going to divide by this and this. That means, so for instance, for 1, just for 1, I would have these as possible solutions. So positive 1, negative 1, positive 1/3, and negative 1/3. So every single one of these could be divided by 4 numbers. Now sometimes we'll get the same thing. So actually maybe I should write them out, right? Because sometimes we'll get the exact same thing. Again, so why would that so for instance, 2, right, is one of our solutions. If I divide 6 by 3, I'm going to get 2 again, right? So we will write them down because I think it'll be easier for us to count. So we have positive 1, negative 1, and then 1/3, negative 1/3. So I divided 1 by positive and negative 1 and positive negative 3. Or you can think of it as, you're going to get the same thing. So if I divide 1 by negative 1, I'm going to get negative 1. If I divide negative 1 by 1, I'm going to get negative 1. So technically, we'd get each number twice, but we only need it one time, no matter how many times we get it. Right? So you can just think of it as dividing by 1 and 3, right? Since we got it all covered with the plus or minus on the factors of P. Right? So we have 2, and we divide that by 1, we're going to have 2 and negative 2. If we divide it by 3, we're going to have 2/3 and, 2/3, yeah, and negative 2/3. We got 3. If I divide it by 1, we'll have 3 and negative 3. If we divide that by 3, I'm going to have 1 and negative 1 again. I don't need to write that down. All right, so now let's go to 6. If we divide it by 1, we have 6 and negative 6. If we divide that by 3, I've got 2 and negative 2 again, so we can skip that. If I divide 9 by 1, I've got 9 and negative 9. I'm going to run out of space. If I divide 9 by 3, I've got positive 3 and negative 3 again. I don't need to write that again. Lastly, 18 divided by 1 is 18 and negative 18. Oops. So I have a little text box here you can't see. And I just hit the text box, and thankfully I didn't stop the recording. Boy, it doesn't really want to write in that spot. But I moved it, and unfortunately now I can't see what I'm up to in terms of time. So now I moved it back. All right, so we've got, and if I divide 18 by 3, I'm going to have 6. I don't need that yet. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible solutions. 16 possible solutions. I don't know why they didn't want to write. 16 possible solutions. Let's do the same thing, but with this one. All right, so now my P is negative 6. It's just the constant. And my Q is 1. All right, so I'm going to have plus or minus. So the factors of 6 are 1, 2, 3, and 6. And we're going to divide that by 1, which I could just divide it by 1. It won't make any difference. So I'm going to have possible solutions are going to be 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. I have 1, 2, 3, 4, 5, 6, 7, 8 solutions. So now, do you see why it might be helpful to divide both sides by their greatest common factor? So while I'm not saying it's a requirement, I now only have 8 possible choices, all of which are integer values that to choose from. Whereas if I don't, I have 16 possible solutions, and 4 of them are fractions. All right, so obviously 1/3, negative 1/3, 2/3, and negative 2/3 are not solutions because I didn't get it with the reduced one. You will have the actual solution can only be the ones that are in the reduced set. All right, so the actual solutions can only be these choices: 1, negative 1, 2, negative 2, 3, where are you? Negative 3, and 6, negative 6. All right? It can't be the other ones. So having that in just creates more possibilities that are wrong in terms of being solutions. All right? So that is the reason why I'm saying you really should reduce first. All right, so now we know it's got to be one of those 8. We're not going to even bother with the other ones. All right, and I have no particular preference on which one I choose. Let's try negative 2. I'm thinking maybe a negative 1, 4, 1, negative 6, because I end up with a lot of positives in the beginning. I don't know. Let's try that out. I could be totally wrong. And I'm thinking if I do 1, it might be too small, and I won't get negative 6 at the end. So let's try negative 2. All right, so bring down the 1. 1 times negative 2 is negative 2. Add, I get 2. 2 times negative 2 is negative 4. Add, I get negative 3. Negative 3 times negative 2 is 6. Add, I get 0. Oh, that was a good guess on my part. I was thinking 1's too small. I'm never going to end up with 6 at the end. And I have a lot of positives, and I want to get some negatives in there. And hopefully that'll counterbalance that, because I'll now have a negative times a negative. And it worked out. All right, so good choice on my part. So now we can just factor the rest. All right, so we have x squared plus 2x minus 3. So 1 times negative 3. Two numbers that multiply to give us negative 3, add to give us 2. Hope you figured it out. 3's only got one set of factors, except for this, differences in sign. But it's only divisible by 3 and 1. So you just got to figure out who's negative and who's positive. Since you've got your middle term there is positive, it's going to have to be 3 that's positive. So 3 and negative 1 are it. All right, so nice easy factoring here at the end. X squared plus 3x plus negative x, there you go, minus 3. First to our group, second to our group, we'll pull out the x. We have an x plus 3, pull out the negative 1, that'll give you the x plus 3. Factor out that repeating x plus 3, and the other factor is what you pulled out, what was left over, x minus 1. All right, and let's not forget this one. All right, so just in case it's all in factored form and you use synthetic division, you can put it back into factored form. So if negative 2 is the solution, x plus 2 is the factor, right? Because you'd subtract 2 from both sides. So I am going to write that down here, and I'd like you to as well. That way you won't forget that that really was a factor. That was just the first one we found. So now our solutions are x equals, I'm a little bit out of space here. So I think you'll be okay if I just say x equals negative 3, x equals 1, and x equals negative 2. Right? So now we know which ones were solutions. And notice they are from the set I circled. So when we look at those 16 possibles, they are all from the ones I circled. Right? And so our actual solutions, we'll put them over here as well. X equals 3, negative 3, 1, and negative 2. Right? Let's do one more. All right, so here we're going to do synthetic division twice. That'll be our last one. Let me see how much left. 1, 2, 3, 4. Yeah, that'll work. There's 4 after that. I don't know how many I did on this one. All right, let's do this one real quick. All right, so we're going to solve f of x equals 3x to the 4th plus 11x cubed plus 11x squared plus x minus 2. All right, pulling out a greatest common factor, factor by groupings, clearly not going to work. It's too many terms, no common factor. So you're going to use long or synthetic division and factor. Because it's to the 4th power, you're going to need to use synthetic division twice. All right, unless we get something we can do factor by grouping with. All right, so let's find out. All right, so our constant term is negative 2. Leading coefficient is 3. Possible solutions are going to be the factors of 2, which are 1 and 2, divided by the factors of 3, which are 1 and 3. All right, so our possible solutions are going to be 1, negative 1, 1/3, negative 1/3, 2, negative 2, 2/3, and negative 2/3. The only ones we can use synthetic division with are the 1, the negative 1, the 2, and the negative 2. So obviously that's where we should start. All right, we got a lot of large numbers and a lot of positives. Let's try the negative 1. I'm afraid if I use the negative 2, it'll get too big because the last number at the end is a negative 2. Let's try negative 2. Let's find out what happens. All right, so we have 3. Oh boy, I made that really small, didn't I? Oh, it'll be fine. 3, 11, 11, 1, negative 2. Nobody's missing, right? One, you got everybody there. A fourth, a third, a fourth power, third power, second power, first power, 0 power. All right, so we'll bring down to 3. 3 times negative 2 is negative 6. Add, we get 5. 5 times negative 2 is negative 10. Add, we get 1. 1 times negative 2 is negative 2. Add, we get negative 1. Oh, I'm good. Negative 1 times negative 2 is 2. Add, we get 0. All right, so you can narrow down your choices by using a little logical reasoning. I didn't think 1 was going to be large enough to take out the 11s there and get 0 at the end. I wasn't sure. Now we don't know. 1 could be one of our solutions, and 1 could have been perfectly fine. But I thought negative 2. Negative 2 was speaking to me. Right? And I thought there had to be a negative in there. Otherwise, our number would be huge. Let's factor the rest. So obviously you can see, once I write it down here, we have 3x cubed plus 5, and I'll just do this too to remind you. our constant, x squared, x cubed. So 3x cubed plus 5x squared plus x minus 1. All right, so not a candidate for factor by grouping. This and this really don't seem to have a whole lot in common. All right, so really doesn't look like a very good choice for us. So we'll use synthetic division again, hence the reason we'll need to use synthetic division again. All right, so now we have 3, 5, 1, and negative 1. And just because one of our solutions was negative 2, doesn't mean we can't use it again if we think that's the one to use. These ones aren't as big. Let's try negative 1. See if that one works. We still have a bunch of positives, so in the front there, let's try a negative. Bring down the 3. 3 times negative 1 is negative 3. Add, we get 2. 2 times negative 1 is negative 2. Add, we're going to get negative 1. Negative 1 times negative 1 is 1. Add, we get 0. Look at that. Got it again. All right, so we have one more solution, and that is negative 1. And we're also going to write the factors at the end, too. So now we can just factor by grouping. So, and I'm going to switch colors. So we have 3x squared plus 2x minus 1. 3 times negative 1 is negative 3. Two numbers that multiply to give us negative 3. Add to give us 2. Was that not the same thing we saw on the last page? I think so. So it's going to be 3 and negative 1. 3 and negative 1. So we have 3x squared. I mean, it's a different equation, but the same numbers. 3x squared plus 3x. Plus negative x minus 1. First to our group, second to our group. We can factor out a 3x. We'll be left with x plus 1. Negative 1, I hope, is screaming at you to be factored out. And you divide those by negative 1, the signs are going to change, and they're going to match. And we can then factor out the x plus 1. X plus 1. And then the leftovers are the other factor. And then let us not forget our other two factors. We had negative 1 as a solution. That means, and then we had an x plus 1 as a factor. Negative 2 as a solution. X plus 2 is the factor. So we'll write those other ones in here. X plus 2 and x plus 1. Right? And then we'll write our solutions. So we already have x plus 1. I'll write them down here too. X plus 1 is 0. X equals negative 1. If 3x minus 1 equals 0, we're going to add 1, divide by 3. I really don't have a whole lot of space. I'm hoping you're okay if I say 1/3. Now I got a little bit more space, but I don't want to make these all too small. And then x plus 2 is 0. X equals negative 2. And then x equals negative 1. So I chose very wisely with the negative 1 because that was the only choice I had. So good for me, because I only have one negative 2, and we couldn't have used a 1/3. So there's all of our solutions. So this one, this negative 1, is multiplicity 2. When we get to graphing, we'll talk about why that's important. Right? But those are our 4 solutions. Negative 1 twice, and then a 1/3 and a negative 2. I'm going to stop this podcast now, because that's a goodly amount of recording. And then I'm going to finish this lesson in the next podcast, and then there'll be one final lesson on solving polynomials, and that'll be a review. Thanks for watching, and bye for now.